Helix Life YouTube channel. Today we are discussing about nuclear physics. The radius of nucleus. The radius of nucleus R is equal to R naught A raised to 1 by 3. The formula is R is equal to R naught A raised to 1 by 3. But R naught is equal to 1.2 into 10 raised to minus 15 meter. A is equal to mass number. A is equal to mass number. Okay. So the radius of the nucleus is equal to R naught A raised to 1 by 3. R is equal to R naught A raised to 1 by 3. Next point is density of nucleus. Density, we know that density is equal to mass by volume. So the mass, we know that atomic number into mass of protons. So that is denoted by m divided by 4 by 3 pi r cube. Okay, where 4 by 3 pi r cube, we know that r cube is equal to r naught whole cube A raised to 1 by 3 whole cube. So that's equal to 4 by 3 pi r naught cube A. So A and cancel. So we get that some constant as density. So density is a constant. So the density of nucleus is a constant. Okay. Next, binding energy. Binding energy is equal to delta mc square. Binding energy is equal to delta mc square. That is binding energy that's equal to ZMP, mass of proton into atomic number, plus mass of neutron into neutron number, that is mass number minus atomic number. So that is the mass of constituent particles minus mass of nuclide will give you delta m mass defect into c square will give binding energy. So binding energy that's equal to ZMP plus A minus Z into Mn minus M into C square. So ZMP plus A minus Z into Mn minus M into C square. And also 1 AMU is equal to 931.5 MeV by C square. So when we substitute C in the C square term, we should multiply it with the 931.5 MeV by C square. Okay. So 1 AMU, this is in the AMU, so we have to multiply this. So delta M into 931.5 is give you binding energy in MeV. So we are finding mass defect in terms of AMU and we multiply with the 931.5 MeV by C square as 1 MeU. So we get delta M in AMU into 931.5 will give you binding energy. Okay, so the binding energy formula, ZMP plus A minus Z into Mn minus M into C square. Binding energy that's equal to ZMP plus A minus Z into Mn minus M into C square. M into all into C square. Also, we have to familiarize with the proton, neutron, electron and also their masses. 1.672 into 10 raised to minus 27 for proton mass. In MeV by C square 938. In AMU 1.00782. Neutron 1.675 into 10 raised to minus 27. MeV by C square 939. AMU 1.00866. For electron in kilogram 9.1 into 10 raised to minus 31. So very low. MeV by C square, that is 0.51. And in AMU, that's equal to 1.00055. Okay. So the mass of proton is equal to 1.672 into 10 raised to minus 27. For neutron 1.675 into 10 raised to minus 27. For electron 9.1 into 10 raised to minus 31. For proton 1.672 into 10 raised to minus 27. Neutron 1.675 into 10 raised to minus 27. For electron 9.1 into 10 raised to minus 31. Okay. So once again, proton 1.672 into 10 raised to minus 27. Neutron 1.675 into 10 raised to minus 27. For electron 9.1 into 10 raised to minus 31. In MeV by C square, for proton 938. Neutron is one more than proton. Okay, so that is 939. For electron 0.51, very small. In AMU, proton 1.00782. For neutron 1.00866. For electron 1.00055. For proton 1.00782. For neutron 1.00866. For electron 1.00055. Okay. For proton 1.00782. For neutron 1.00866. For electron 1.00055. Okay. So you get the idea. Next we have to study about magnetic moment. Magnetic moment, that is interaction of charges with the magnetic field. For in the case of atom, you know that there is a some nucleus inside nucleus inside an atom, in which a nucleus inside is the atom. There was a nucleus inside that, and electrons are revolving around the nucleus, and we know that electron has orbital and spin motion is there. So the orbital with the orbital motion, there is a magnetic moment GL mu b under root L into L plus 1. Mu s is the spin motion of electron. For that there was a magnetic moment Gs into mu b under root S into S plus 1. For GL is equal to 1, Gs is equal to 2, and mu b is equal to EH cross divided by 2me. For magnet, that is equal to 9.27 in 10 raised to minus 24 joule per Tesla. This is for the case of atom. But we are now studying about the nucleus. For nucleus, we know that there is proton and neutron inside the nucleus. The protons and neutrons have some orbital and spin motions. So for that, some orbital magnetic moment mu L is equal to modulus of mu L is equal to GL mu n under root L into L plus 1. Mu s is equal to GS mu n under root S into S plus 1. Mu L is equal to GL mu n under root L into L plus 1. Mu s is equal to GS mu n under root S into S plus 1. So once again, mu L is equal to GL mu n under root L into L plus 1. Mu s is equal to GS mu n under root S into S plus 1. Mu n is equal to 5.05 into 10 raised to minus 27 joule per Tesla. Mu n is equal to 5.05 into 10 raised to minus 27 joule per Tesla. Mu n is equal to 5.05 into 10 raised to minus 27 joule per Tesla. So mu L is equal to GL mu n under root L into L plus 1. Mu S is equal to GS mu n under root S into S plus 1. where mu n is equal to 5.05 into 10 raised to minus 27 joule per Tesla. For we know that there is a proton and neutron is there, so we have to substitute GL and GS for that values. Okay, for that GL and GS is that GL and GS, GL for for proton, that is 1, for neutron 0. GS is 5.59 for neutron, minus 3.83. For mu, that's equal to 2.729 mu n. For mu, that is equal to minus 1.913 mu n. Okay, so we have to study that thing. Proton, GL is equal to 1. For neutron, GL is equal to 0. GS is equal to for proton 5.59, and for neutron, that is minus 3.83. For mu for proton, that's equal to plus 2.729 mu n. For neutron, mu is equal to minus 1.913 mu n. Okay, for proton, GL is equal to 1. Okay, neutron 0. GS is equal to for proton 5.59. For neutron, minus 3.83. For proton, mu is equal to plus 2.729 mu n. Neutron, minus 1.913 mu n. Okay, so once again, photon, GL is equal to 1, neutron 0, GL 5.59. For neutron, minus 3.83. Proton, mu is equal to plus 2.729 mu n. For neutron, minus 1.913 mu n. So next we have to study about quadruple moment. So the quadruple moment will give you the measure of the deviation of the shape of the nucleus from spherical symmetry. So the quadruple moment will give you the deviation of the shape of the nucleus from the spherical symmetry. So we know that the quadruple moment of the nucleus is equal to 0, because it is the deviation of the shape of the nucleus from the spheroidal spherical symmetry, that is quadruple moment, that it is not 0 for a nucleus. So for less than 0, that is Q is negative, means the shape of the nucleus as oblate. Q is less than 0, that is negative, means oblate. Q is less than 0 means negative, that is shape is oblate. Q greater than 0, that is positive, that is prolate. The shape of the nucleus is prolate. Q greater than 0, Q is positive, the shape of the nucleus is prolate. Next, shell model. Shell model is also called single particle model. Shell model is also called single particle model. Shell model is also called single particle model. The properties of nucleus is given by the last unpaired nucleon. The properties is depend only on the last unpaired nucleon. Okay, the protons and neutrons arranged in separate shells, that is S, P, D, F, G, H type shells are there inside the nucleus. Also, the protons and neutrons are arranged in separate shells. Protons and neutrons are arranged in separate shells in the nucleus. So, shell model is a single particle model, and the properties of nucleus is determined by the last unpaired nucleons, and the protons and neutrons are arranged in separate shells. Most of the nucleus are present. Most of the nucleus are paired. That means that nuclear spin and magnetic moment becomes 0. the most of the nucleus are paired. Paired means there is no unpaired nucleons. So the nuclear spin and magnetic moment become 0. So the most of the nucleons are paired. The nuclear spin and magnetic moment become 0. Shell model explains the stability of the nucleus. Shell model explains the stability of the nucleus. Explains the stability of the nucleus, and also it confirms existence of magic numbers, that is 2, 8, 20, 28, 50, 82, 126. So the magic numbers are 2, 8, 20, 28, 50, 82, 126. Magic numbers are 2, 8, 20, 28, 50, 82, 126. These numbers are magic numbers. It confirmed by the Shell model that these number of protons and neutrons show some extra stability. It explained by Shell model. Shell model, the properties of the nucleus already determined by the last unpaired nuclei, and the neutrons and protons are separately arranged inside the nucleus, and it is paired. That means the nuclear spin and magnetic moment is equal to 0. Next, what is the application of Shell model? First application, and for that, finding nuclear spin and parity. We know that all paired means there is nuclear spin and parity is nuclear spin and magnetic moment is equal to 0. For finding spin and parity, spin is angular momentum J and parity pi can be understood from this Shell model. So consider the example of oxygen 16-8. So we know that the mass number of oxygen is 16 and atomic number is 8. So the proton number of oxygen is 8. So 16 minus 8 will give you neutron number, that is 8. So P8 and 8, we can arrange the neutrons and protons in the shells like this: S1 by 2, 2, P3 by 2, 4, P1 by 2, 2. 2J plus values are 2J plus 1 nucleons are arranged in shells. So we can fill like this. You know this arrangement. Okay. So we have J is equal to half, means half into 2 plus 1, that's equal to 1 plus 1, 2. So S1 by 2 shell which consists of 2 nucleons. Here also 2. 3 by 2 into 2 plus 1. So 3 plus 1, 4. So P3 by 2 consists of 4 nucleon. Like that it continues. So we know that P8, 8 protons. So 2 plus 4, 6 plus 2, 8. So here also 8 neutron, 2 plus 4 plus 2, that's equal to 8. So all are paired. All are paired means spin is equal to J is equal to 0 and pi is equal to positive. Okay. So always spin is equal to 0 for all are paired. For all are paired means the spin is equal to 0 and parity is equal to positive. Okay, and for even case, J is equal to spin is equal to 0. For even spin is equal to 0, parity is equal to positive. Okay, and here even odd situation is there and odd even. So here carbon 613 means proton number 6, neutron number 13 minus 6, that's equal to 7. So neutron number is 7. So we have to fill these things. Proton is paired, S1 by 2 2, P3 by 2 4, paired. But in the case of neutron, S1 by 2 2, P3 by 2 4, P1 by 2 1. So there is 1 is unpaired. So J is equal to last unpaired nucleon, that is equal to J is equal to half, and parity is equal to minus 1 all power L. The L is for corresponding P, L is equal to 1. For S, L is equal to 0, P, L is equal to 1, D, 2, F, P, D, F, G, H, like that it goes on. So minus 1 power L, that is minus 1 power 1, that's equal to minus 1. So the parity is minus 1 and the spin is half. So J pi is equal to half minus. Okay, spin and parity like that. For no doubt case, we have here P is equal to 7, N is equal to 7. So J1 is equal to half here, L1 is equal to 1 for P, J2 is equal to half, L2 is equal to 1. So the formula to find the odd nuclei, for that case we have to do North-Beam rule. For that, just add J1, J2, L1, L2. J1 plus J2 plus L1 plus L2. If it is even, you have to do for that J is equal to J1 minus J2 modulus. It is odd means J is equal to J1 plus J2. Parity is same, that is minus 1 power all power raised to L1 plus L2. Okay. So once one more time you have to revise these things. That is odd case, you have to add all these things, J1 plus J2 plus L1 plus L2. If it is even, J is equal to modulus of J1 minus J2, and if it is odd, that is equal to J is equal to J1 plus J2, and pi is equal to minus 1 all power L1 plus L2. So here in the case J1 is equal to half, J2 is equal to half, L1 is equal to 1, L2 is equal to 1. So half plus 1 plus 1, that's equal to 3, odd. Odd in the case, that is J is equal to modulus of J1 plus J2. That's equal to modulus of half plus half. That's equal to 1. So 1 is J, spin we got, and pi, parity, that's equal to minus 1 all power L1 plus L2. L1 and L2, that's equal to 1, 1. So minus 1 all power 1 plus 1, that is equal to 2. That's minus 1 all square, that's equal to 1. So like that we have to find spin and parity of all the cases. When even cases all are paired, spin is equal to 0, parity is equal to positive, and in even odd case we have to consider the last unpaired electron. Okay, and also we have to consider for an odd case, we have to consider about the North-Beam rule, that J is equal to J1 plus J2 plus L1 plus L2. If it is even, J is equal to modulus of J1 minus J2. If it is odd, that is J is equal to J1 plus J2. And pi is always minus 1 all power raised to L1 plus L2. Okay. And we have to consider the shell model in which the neutrons and protons are filled like this: SP, D, S, F, P, G, D, S, H, F, P, I, G. Like that. S we know that 1 by 2, 2, P 3 by 2, 4, P we have L plus half, L minus half. L is equal to 1 for P, 1 plus half, that is 3 by 2, 1 by 2 for P. So there is a splitting, we know that things. S is equal to 1 by 2, P is equal to 3 by 2, 1 by 2. D is equal to 5 by 2, 3 by 2. SPDF 7 by 2, 5 by 2. So like that we have to know about the splitting of the shells, and these things are arranged like this. there was D, there was a S after D. There is a change in the arrangement. So you have to remember the things. Okay. Next, we have to understand about the magnetic moment in the case of J is equal to L plus half and J is equal to L minus half. For J is equal to L plus half, you remember the formula as GL into J minus half plus GS by 2. For L minus half, GL into J plus 3 by 2 divided by J plus 1 minus GS into J divided by 2J plus 1. 2 into J plus 1. So, one case, that is J is equal to L plus half. When it is J is equal to L plus half, the magnetic moment, that is by shell model, J is equal to L plus half is the configuration. Then mu J, that's equal to GL into J minus half. GL into J minus half plus GS by 2. Okay. GL into J minus half plus GS by 2. Okay. GL into J minus half plus GS by 2. For J is equal to L minus half, for GL into J plus 3 by 2 divided by J plus 1 minus GS J by 2 divided by J plus 1. Okay. So, you can study these things by comparing these things. So, for L plus half, GL into J minus half plus GS by 2. Okay. So, for J is equal to L minus half, we have to multiply both sides with the J into J plus 1. J into J plus 1, and also we have to change minus with plus, plus with minus, and 1 by 2 with the 3 by 2. So, GL into J plus 3 by 2 into J by J plus 1 minus GS divided by 2 J into J plus 1. So, you have to remember one equation only. For J is equal to L plus half, GL into J minus half plus GS by 2. GL into J minus half plus GS by 2. GL into J minus half plus GS by 2. For L minus half, GL into J minus half into J by J plus 1 plus GS by 2 J by J plus 1. And we have to change with the plus with minus with plus, plus with minus, and 1 by 2 with the 3 by 2. Like that, we got the two formulas. For these equations, you have to remember this equation only. J is equal to L plus half, GL into J minus half plus GS by 2. GL into J minus half plus GS by 2. So, we will remember the GL and GS for proton and neutron, all these values. Okay. GL for proton 1, neutron 0. GS for proton 5.59, for neutron minus 3.83. Mu, that's equal to, for proton 2.729 mu n, for neutron minus 1.913 mu n. For proton, GL is equal to 1, GS is equal to 5.59, mu is equal to plus 2.729 mu n. For neutron, GL is equal to 0, GS is equal to minus 3.83, and mu is equal to minus 1.913 mu n. Okay. Okay. Next, we have to study about the thing quadruple moment. Quadruple moment formula is Q is equal to minus of 2J minus 1 divided by 2 into J plus 1 into expectation of R square, that's equal to minus of 2J minus 1 divided by 2 into J plus 1, 3 by 5 R naught square A raised to 2 by 3. So, this is the equation for quadruple moment. Q is equal to minus of 2J minus 1 divided by 2 into J plus 1, 3 by 5 R naught square A raised to 2 by 3. R naught is equal to 1.2 for me. So minus of 2j minus 1 divided by 2 into j plus 1. R naught 3 by 5, R means R naught square, a raised to 2 by 3. Okay. Next, we are dealing with the one problem. We know how to fill the neutrons and protons inside this. So we get proton as odd. So we have to consider only this case. Proton as equal to P is equal to 13 for this. So we fill like this thing, and for that j is equal to 5 by 2. Okay. So j is equal to 5 by 2. So that is L plus half configuration. So for that we know the magnetic moment mu j. For L plus half we studied the thing, that is GL into j minus half plus GS by 2. So j is equal to 5 by 2. Substitute the thing GS. This is for proton. For proton GS is equal to 5.59, and substitute the thing, and we got the value as like this. And quadruple moment, we know that Q is equal to the formula as minus of 2j minus 1 divided by 2 into j plus 1 into 3 by 5 R naught square, a raised to 2 by 3. 2j minus is considered. If we get minus here, we have to multiply with minus, and the answer will be positive. The quadruple moment for the formula is minus of 2j minus 1 divided by 2 into j plus 1 into 3 by 5 R naught square, a raised to 2 by 3. We substitute the j with 5 by 2 and R naught as 1.2 for me, and a is here 27, and substitute the value, and we got the answer. Okay, so this is all about the shell model. We studied about quadruple moment, magnetic moment for j is equal to L plus half, L minus half, and the arrangement not deemed rule. Okay. Next, we are studying about liquid drop model. Liquid drop model, for that the concept is to find the semi-empirical formula for binding energy. Binding energy, we know that binding energy is directly proportional to mass number, because binding energy is directly proportional to the volume energy. Volume is equal to R cube, so that a raised to 1 by 3 whole cube, that is directly proportional to A. So BV is equal to AVA. Surface energy Bs is directly proportional to 4 pi R square. So surface energy is equal to minus AS, a raised to 2 by 3. Only volume term only positive, balance all terms are, other terms are negative. Coulomb energy BC is directly proportional to Z into Z minus 1 by 2 into Ke square divided by R naught, a raised to 1 by 3. Why Z into Z minus 1 by 2? These are four pairs. That many pairs are there. So we consider Z into Z minus 1 divided by 2 K square divided by R naught, a raised to 1 by 3. So we have to study this thing only, minus AC Z into Z minus 1 divided by a raised to 1 by 3. And for asymmetry, n minus Z all square divided by A. Okay, so Z we have to substitute, n we substitute as a minus Z, so a minus 2Z is here. So minus a minus 2Z all square divided by A. And for pairing, BP is equal to plus or minus AP, a raised to minus 3 by 4. For even it is positive. For odd it is negative. Odd even it is equal to 0. Okay. So these many terms we have to consider. So the formula is AVA minus AS, a raised to 2 by 3 minus AC Z into Z minus 1 divided by a raised to 1 by 3 minus a minus 2Z all square divided by A plus or minus AP, a raised to minus 3 by 4. Okay, the binding energy formula AVA minus AS, a raised to 2 by 3 minus AC Z into Z minus 1 divided by a raised to 1 by 3. Why it is a raised to 1 by 3? We know that the formula, as I said, Coulomb energy, the formula is directly proportional to 1 by R. Okay. Coulomb potential, that is directly proportional to 1 by R. So that is R naught, a raised to 1 by 3. And also asymmetric energy, that is minus a minus 2z all square divided by a, plus or minus ap a raised to minus 3 by 4. For pairing, it is positive for even, odd it is negative, odd even 0. So binding energy ava minus as a raised to 2 by 3 minus ac z into z minus 1 divided by a raised to 1 by 3 minus a minus 2z all square divided by a plus or minus ap a raised to minus 3 by 4. So you have to remember the things. ava minus as a raised to 2 by 3 minus ac z into z minus 1 divided by a raised to 1 by 3 minus a minus 2z all square divided by a and plus or minus ap a raised to minus 3 by 4. Okay. For stable isobar, we have to find the binding energy derivative with respect to z, and we get the stable isobar formula. Z is equal to a divided by 2 plus ac divided by 2 into a raised to 2 by 3. Okay, so these are constants for Coulombic term and it is asymmetric term. So z is equal to a divided by 2 into ac divided by 2 into a into a raised to 2 by 3. Z is equal to a divided by 2 into ac divided by 2 into a. A means constant of asymmetric, a into a raised to 2 by 3, that is mass number all raised to 2 by 3. So z is equal to a divided by 2 into 2 plus ac divided by 2 into a all multiplied by a raised to 2 by 3. Okay, so you have understood the things. Next we are discuss about a collective model. For collective model, we are discussing only the thing. One thing is that rotation energy is given by modulus of j square divided by 2i. That is, j square is h cross square. J is equal to h cross under root j into j plus 1. So j square is h cross square j into j plus 1 divided by 2i. So the only even levels are exist for rotational levels. Even states are exist, that is 0 plus, 2 plus, 4 plus, 6 plus. So we know the ground state as we substitute j is equal to 0, that is 0. For j is equal to 2 into 3, 6 h square h cross square divided by 2a. For next level, there is no 3, only even states are there according to collective model. So the rotational levels are, even states are there, the rotational energy levels. So h cross square divided by 2i into j plus 1. The levels are 0 plus, 2 plus, 4 plus, 6 plus, 8 plus. The energy formula h cross square divided by 2i into j plus 1. H cross square divided by 2i into j plus 1. Okay, ground state is 0, first excited state is 2 and second excited state is 4, like that even states are there. And next we are studying about gamma decay. For gamma decay, we know that there was a transition between isomers only. That is, for an isomer, different lifetime only. Okay, the isomer for gamma decay only happens when some nucleus in some excited state to ground state coming by decay by through gamma decay. So when we are considering XZA star decay to XZA by emitting gamma, the gamma photon must carry at least 1 unit of angular momentum. Okay, so when we are considering Ji pi I is as the initial, Jf pi f as the final, and there was a gamma emission, gamma decay. So we know that there was some angular momentum for this, so that is Ji minus Jf to Ji plus Jf possibilities. So when we are considering 3 by 2 minus and 5 by 2 plus, there is a possibility of 3 by 2 minus 5 by 2 to 3 by 2 plus 5 by 2. So 1, 2, 3, 4. So the gamma transition, there was a multiple transitions. If the parity is different, if the parity is different, if the parity is same, the even angular momentum states are electric. If the parity is different, even states are magnetic. Okay, so the parity is same. For the parity is same, even states are for electric. Okay, so if you are considering the problem, you can understand better. That is Ji pi I for PB 82-207 is given by 1 by 2 minus, and Jf pi f as 3 by 2 minus. Okay, so the transition allowed between that L is equal to 1 by 2 minus 3 by 2, that is 1, and 1 by 2 plus 3 by 2, that is 2. So 1 and 2 are the two angular moments, and pi total is equal to pi I into pi f, that's equal to even. So there is no parity change, so electric are even only, so the 2 as even, so that is electric. E2 and M1 is there. Okay, next when we are considering G 9 by 2 plus 2, P 1 by 2 minus, so 9 by 2 plus and 1 by 2 minus. So L is equal to 9 by 2 minus 1 by 2. 4 and 5 are the possibilities. Pi total is equal to minus 1. That is, there was plus 2 minus, there was a parity change is there. Okay. So the odd will goes to electric, even will goes to magnetic. So there is no parity change, even transitions are electric, odd are magnetic. If there is a parity change, there was some difference, that is odd will goes to electric poles and odd even will goes to magnetic. There was a change. Okay, so these are the concepts we studied in nuclear physics. So thank you for watching and keep learning.